All right, good morning and happy Friday. I'm planning on doing the LeetCode contest from last week, 313, virtually. So here we go. Open these guys up. Time to shine. Common factors of A and B. I don't see how 4 divides 6. Oh, how many common factors there are. I see. He says the count of common factors, right? Okay. Alrighty. So 1 through square root of the maximum. Okay. All right, common factors. 36 a.m. Let's see. So for x in range, maximum of a and b, the square root of that, right? So the floor, the square root, this guy, 1. If not x, oops, a, which is x, and right, so basically x evenly divides each of these. Then we'll increment the count, which will be returned. And so count plus equals that, and return the count in the end, something like that. Okay, run the test cases 2 and 1. That is not right. Oh, there. Oh, I should go to half then. Okay. Let's do this. There we go. 3 and 2. Wait a minute. That's not right. Oh, plus 1 for it to be inclusive. Okay, 4 and 2 looks good. Uh-oh. Output is 7, but we expect 8. Divided by 2 plus 1. Strange. What is it I'm missing? Is the ceiling? Ceiling of this guy plus 1? I'm like not going far enough. Let's see. 85, 85. Should be 8 instead of 7. What the heck? Common factor divides them both. Let's see. If this, then print x. Let's do this. 1, 2, 3, 4, 5, 6, 7. What is the 8th one? Oh, if they're equal, then that's a corner case. I see. Okay. So missing corner case of plus 1 when a is equal to b. Okay. Yeah, plus equals this guy plus int a equals b. Right, that's cool. Okay. Do the example test cases too. Make sure those are cool, right? Those are cool. Oh no. Hold on. It's only at 1,000, so let's just go to 1,000, whatever. Okay. 1, 885, 885. Okay. That's a KISS type thing. Keep it super simple. Okay. 5:40 and about 4 minutes with 2 bugs. Yeah. All right, just do a linear scan of 1 to the max and inclusive. Solutions. Outline. JavaScript. Python 3. Rust. C++. And I wonder, just shorten this up too, right? So count it as the sum of those, or yeah, the length of that, whatever it could be. Lambda self AB. Length of x for x in range 1 to the maximum A and B inclusive, if not A modulus x and oops, hold on. All right, so it evenly divides A and B. Should be good. That's cool. Let's see. And the maximum value is up to 1,000, right? Right, for consider all values from 1 to the maximum of A, B, inclusive. Denominator values x. From 1 to the maximum of A and B inclusive. And return the count of we don't need to say that, right? Read the problem statement if you don't need more. Okay, so here we go. Let's just do this real quick in the other languages and then move on. And B. Okay, so we're going to consider all x. Oops. So maximum A and B is map each ith value to I+1 for 1 to maximum A and B inclusive. Filter. Each value x not. All right, so A is evenly divisible by x and B is also evenly divisible by x. The length of that. Already, it's cool. Looks good. It's accepted. Okay, let's do Kotlin. Do this as lambda as well. Int array sub max a b assigned to it map it plus 1 or 0 to maximum a to b, or from 1 to maximum a to b inclusive. Filter a divided by it to 0 and b divided by 0 dot size. Looks good. That's cool. Alrighty. Do this in Rust and C++. Turn the count in the end. Auto x1. X is less than or equal to the maximum A and B inclusive. And plus equals and A is evenly divisible by X, and B is also evenly divisible by X. It's cool. Okay. Then let's do Rust. Okay, so we want to do 1 to the maximum of A and B inclusive dot filter each x a modulus x equals 0 and right, but A and B are evenly divisible by x. The length is I32. Oh, collect and then length, right? Collect as a 32 vector. And the length of that thing is I32. Oh. Oops, collect. Oh, dang. Okay, what's going on? Oop, I need to like that. Yay, okay, that looks good. It's cool. Alrighty, let's move on. Doesn't have to be perfect, that's good enough. Okay. And Q1 took about 15 minutes. Okay. Q1 took about 15 minutes. Okay. Q2. Hourglass cannot be rotated. Okay. Interesting. Pretty small. Okay, well, since M and N are at most 150, brute force will be fine, right? I think, yeah, brute force is expected to be accepted. All right, best is that. They are at least 3 by 3, so that's cool. Turn the best at the end. Let's do this. MN is length A, the rows, and then columns range M -3 0 1 2 3 inclusive, non-inclusive. Yeah, that should be fine. Or j in range -3. Okay, and then just add them up. Let's create a function. F is hold on. Call this a candidate function. Given I and j, it will return. Oh, let's just do the same. Candidate equals lambda ij a sub I sub j plus a sub I sub j plus 1 plus a sub I sub j plus 2 plus a sub I plus 1 j plus 1 plus a sub I plus 2 j plus 1 plus 2. Best is the maximum of best and the candidate to ij. Something like that. Nothing too fancy. Should be fine, I think. 30 and 0, and that's not right. Okay. Okay, so something's wrong with this. It should be inclusive. Uh-oh. Hold on. 9j is 0. That should be a candidate, right? 0 through m is 3. Is inclusive, right? Hold on. It's 35 here, but then it goes out of range in the other one. What? What did I do? Oh, okay, it looks fine. Okay. All right. How long did that take? It took about 3 minutes. Okay. Q2 took about 3 minutes. Okay, cool. Nothing too fancy. All right, just brute force. Let's do this in languages and move on. All right, a few solutions. Kotlin, JavaScript. 3. Rest. C++. Okay, stick that there. And I'm gonna just copy and paste this. I don't have to type it in all the time. Okay. Vector of integers. Vector of integers. Shorten this up a little bit. Okay, auto candidates. J. Turn this guy. 0, I plus 3 is a equal to M. N is here. We said size. And the amount of rows and the amount of columns. Which ith row and jth column. And best, return in the end here. Best is the maximum of itself, the candidate at ij. Alrighty. Whoa. A declared here, it cannot be explicit. Okay, yeah, I gotta capture matrix by reference. Looks good. Okay, that's cool. Bam. Right. Let's move it on. Nothing too fancy. Okay. Best. And the best in the end. All right. Let's in is the length. It's the amount of rows, amount of columns. Candidate J. And paste this guy. Plus 3 is equal to n. 0, j plus 3 is equal to n. Oops. J. This is the maximum of itself when the candidate in IJ. Alrighty, looks good. It's cool. Okay. All right, Kotlin. Yes, return here. And here. Amount of rows and amount of columns. Candidates. As an integer, choose integer. Return. Get this guy again. I need to type that out. Okay. N 0 until M, J, and 0 until N. Best is the maximum of itself and the candidate at IJ. Alrighty. Uh-oh. Oh yeah. Until M minus 3. Right. Hold on. Minus 3 inclusive. Looks good. It's cool. Okay. Kotlin, JavaScript. Okay. Rust, save the best for last here. Already. Readable best is initially that. Return best. And that mn. Length, the rows, columns. Oops. And candidate equal IJ. And copy and paste this again. That guy. For I in 0 until M minus 3 inclusive. J in 0 until N minus 3 inclusive. Best is the maximum of itself and the candidate IJ. Okay. That's good, I think. Oh, cannot infer type. Really? Type annotation is needed. Type must be known at this point. Interesting. Oh wait, I can't index I32, right? It has to be this whole thing is I32. As I32. Uh-oh. Cannot infer type. Type annotation is needed. What? What do you mean you can't infer the type? Why does it not know what the hell this thing is? A sub I sub j. What the heck? Okay, it's I32. Type annotation is needed. What? Oh, maybe I need the type annotations here. These are all U sizes, right? Maybe it's happy with that. Yay, okay, that's cool. And the Rust compiler can be very verbose, similar to C++, but sometimes worse, it seems. Okay, good enough. Nothing too fancy. And then, right. All right. Since M n less than or equal to 150 root force is AC, is accepted. I consider all top left cells I, J as candidates. And return the maximum sum, right? Our class sum as the best answer. Alrighty, that's good. Nothing too fancy. Alrighty, that's that. And we have 1 hour left. Okay. So, all right. Q2 took about 15 minutes. And 1 hour left. This is cool. It says the same number of bits as num2. The value of that is minimal. Num1 and num2 are 10 to the 9th. Note that the XOR is a bitwise XOR operation. The smallest ones that have the most in common. X is uniquely determined. Okay, well, there's only 32 bits, but we can move them all around. We want to have the same bits, like cherry pick, right? Let's just call this A and B. Cherry pick the same bits from A and B such that the XOR cancels them out. X XOR X 0. Then cherry pick the remainder as right most bits, right? So basically a greedy solution is the game plan. Right, game plan is greedily consume the bits as follows. Okay, so here we go. 6:04 p.m. See how many minutes we end up with. Okay, so bits is the binary representation. Hold on, let's do this. We have A is 10. It should be 1010. It should have 2 bits. Binary representation of A. Binary representation of A. So 012 onwards. count the ones. Length of each character for character, and this split if character is equal to 1. Oops, that didn't work. There's no length. Oh, do this. Oh, no way. Really? Hold on. Oh, okay. Split on empty space. Really? It should be an array, I thought. Oh, just turn this into a list, right? Okay, let's do this. Let's do splitting it. Let's turn this into a list. Characters. Okay, that's what I want. Oh, okay, there's my bits. And we'll cherry pick those bits. From left to right, or should call this a count of bits. Okay, and then for position I in 31 down to 0 inclusive. Okay, so best 0, turn the best in the end. If a and 1 shifted left by I, best or equals 1 shifted left by I. Basically set that bit in best. And then decrement the count. Okay, so count is based on B, right? It says the number of sets bits in there, X with that. So the bits in B, I'll just call this here bits. Okay, if bits and bits equals 1. Okay, and then bits. I have to set it from right to left. Hold on, let's do this. Over I and range. Bits and it's not set. We'll cherry pick them from right to left. SR equals I. Okay, something like that. 3 is the best answer, and then 3 is the next best answer. That's cool. Yay. Okay, 609. Okay, about 5 minutes. Implementation. Oops, implementation. And on 3, which oops. Yay. Okay, cool. Right. Here we go. Okay, a few solutions. Greedily cherry pick the bits set in the best answer by consuming the quantity of bits set in B by one XORing bits set in A from left to right. I guess a most significant bit 32, I guess, to least significant bit inclusive. And then setting the remainder bits from right to left. That is least significant bit to most significant bit, 0 to 31 inclusive. Okay, so that's the strategy that worked out. Pretty solution. Let's jam on this real quick in the other languages. Plus, plus, okay. It's cool. All right. A, B, best, turn best in the end. Okay, so count the bits. Bits, let's do this actually. Int bits is built-in hop count of B. For 5 from 31 down to 0 inclusive. If bits and A, basically that bit is, the ith bit is set in A, then best, equals 1 church left by I, and subtract bits, and then in the opposite direction from 0 to 31 inclusive, we have a bit to set, and oh, and we just have a bit to set. Right, we had actually, yeah, hold on. We have a bit to set. Oh, does this matter? This should be best is not already set, right? It's not set in A. It's not set in best. I guess if it's not set in A, it's the same thing as not set in best. Right, because we're only setting those. Okay, that works. It's derived, but okay, this is a little bit more straightforward, right? If you aren't already set in best, you should set it in best on the second pass. A little bit more straightforward than using A bits, and the bit is not set. Right, basically the same thing. Okay, that's cool. It's good. Okay. JavaScript. A, B, best. Best in the end here. Okay, so let's do this. X equals 10. And then the binary representation of X is X dot toString 2. Split filter character is equal to 1 dot length. Okay, so that's what I want. Fits equals B. Okay. Or I equals 31 down to 0 inclusive if it's and it is set in A. And store equals left by I. That's the bits. Okay, and then second pass 0 to 31 inclusive. Okay, let's just copy and paste this here real quick, and then best is not set, then we'll set it. Oh, best. A is set, then we'll set it here. Oh, it's not. Oops. It's not set there, we'll set it. Okay, cool. Ready? Kotlin next. Okay, A, B, best. That's what we're turning in here. Okay, so for Kotlin toString 2, we can do the same thing, right? For our bits, e.toString 2 dot toChar array dot filter it character is 1 size. Let's see if that works out. I think that's okay. Put the bits and B. 2. 12 is 110, 0. Okay, that looks good. For I in 31 down to 0 inclusive, if bits exceeds 0 and 1 or A and 1 shifted left by I not equals 0, then, oops, what did I do? Oh, okay, go. We want to say best equals best or 1 shifted left by I and subtract bits. Okay, and then for I and 0 and to 31 inclusive, the other direction. Oops, hold on. Okay, if best in that is equal to 0, it's not set. Okay, that looks good. Looks good. It's accepted. Okay, and then rest, say the best for last here. Where's rest? Rest. A, B. Mutable best is 0. Return best in the end. And or I in 0 to 31 inclusive in reverse. If see, let bits. How am I going to accumulate the bits for B? Equal bits. Let's just do it the long way. How about for I in 0 to 31, if B and 1 shifted left by I, it's not equal 0. Increment the bits. Okay, so if we have bits to set and A and 1 should look like I, it's not equal 0, then best or equals 1 should look by I, bits subtracted by 1, or I in 0 to 31 inclusive. If we have some bit sets and best not set at that ith bit, best this one should left by I, it's decremented. Okay, looks good. Looks good. Okay. All right, crudely cherry pick the bits set in the best answer by consuming the quantity of bits set in B. 1 XORing bits from left to right, most significant and least significant bit from 31 to 0 and inclusive, and then setting the remainder bits from right to left, the least significant to most significant bits 0 to 1 inclusive. Right. So cancel out these ones, and yeah, this one's okay. And it's Q4 time. We have 42 minutes for Q4. Awesome. Okay, plenty of time. 42 minutes remaining in the contest for Q4. Okay. And the maximum number of operations need to delete all of S. Maximum. Delete the entire string or delete the first half. Two operations. Maximum number of operations needed. The second operation, we cannot delete ABC again because the next occurrence of ABC does not happen in the next 3 letters. Delete the first I letters if the first I letters of S are equal to the following I letters in S for any I in the range 1. Delete the S divided by 2 inclusive. Okay, since AB is equal to AB, you can delete it. It's 4,000. It's not that big. We do not want to delete the entire string, right? This is not what we want to do. So we want to cherry pick this part equal to the next part as often as possible. Delete the first letter of A. Delete the first 3 letters. Stop length divided by 2. The first half. if they're all equal. So why can't we just delete A and then delete A again? The first I letters of S, if the first I letters of S are equal to the following I letters of S for any I in the range 1 through the length of the string divided by 2. I wonder why we can't just delete A a couple times, right? You delete A the first time. Can you just delete A again? 1, 2. Oh, because then you have to delete all the thing after that. So this buys us time consuming that part. It seems like we need like a rolling hash or some way of saying, okay, this is what is available, and we can greedily consume that. Okay, so right, the game plan. Greedily consume, right? Smallest applicable prefix whenever possible. And the alternative, right? Because the alternative is to take I delete the entire string. Right, which we don't want to do, right? Which we don't want to do. We're trying to maximize steps. Okay, that's the game plan. Example 3, we know the corner case is this guy. Okay. So basically finding pattern in text efficiently. Right, so the in is equal to 4,000. So the question then is how to efficiently find prefix pattern in text. I wonder if I could start with brute force. Maybe start with brute force, then optimize. Right, brute force TLE might be a good way to start. Is there an A? No. Is there an AB? No. Is there an ABC? Oh, yes, yeah, there is. Okay, so delete that chunk. All right, is there A? No. Is there an AB? No. Is there an ABC? No. Okay, so let's do that. Do brute force first. Brute force, PLE. consider all possible prefix. Okay, so I can be our starting point, and then J can be the ending point, and then look for that next chunk within the input string. Or I of length K, and that might work better. Okay, so 0, turn the count in the end here. Okay, so while I is less than n. Okay, so for K n range from 0 to how much is left? N minus I divided by 2 inclusive. Right, so let's see if that works out as I'm expecting. For example, 1. Okay, so n is 10. I is here and n is there. And how many k's would we want to consider, right? I plus k. At the very most, we'd want to go up to right, n minus I divided by 2, which is 5, non-inclusive. Okay, yeah, it's non-inclusive. Okay. If the substring I to I plus k is equal to substring from I plus k until I plus 2 times k. Right, look for length k. Then we'll consume it. Okay, so we'll call this OK equals false. Right, call this take. Take equals 0. Take equals k from I, break. If not take, then yeah, this goes 1, and then break out. We have to consume the rest of the string in that case. Otherwise, at least one. Yes, sir. I think everyone's sleeping, partner. I think they're all asleep. So, do you want to? Yeah, I think mom's asleep and everyone else is asleep. Do you want to watch some cartoons? Yeah. Okay, I'm doing a little bit of studying. You want me to help you turn it on? Yes. Okay. Okay. Get my music back going here. Flex equals take. Wait, hold on. So if we take times 2, right? So say we take the first 3 letters, 1, 2, 3. Yeah, okay, so that should be fine, right? I plus equals take. Okay, that is not right. And my logic seems off. Hold on, let's look at this closely. Okay, so we're going to consider A, B, and K is 3. I to K non-inclusive is ABC. And then from I to K inclusive, I to K times 2 non-inclusive. It should be that guy. Let's just put a debug print in here. My logic seems to be off. Okay, I and K. All right, so those are the candidates. A and B, A, B, C, A. Oh, count always equals 1. That's equals 1. Yeah, okay. 2, 3, and 5. Oh, that's not right. Okay, so that logic is right, except for this one. Okay, what's going on? That's not right. I equals 2. Take. It's equal, it's not equal. Okay. A equals A is 1. So A equals A again, this is not correct. Because we can take a bigger one. Or we want to take the AAB. Hold on. It should be 4. 1, 2, 3, 4. Okay, so we want to take from biggest to smallest then. N minus I divided by 2. Oops, I think I want to do that actually. while. Take as a candidate. Okay. Take the biggest to the smallest. Oh, K is not defined. Oop. K is what we take. Uh-oh. I believe equals K. Oh, okay. If not K, then break. Yeah, so. Oh, I need to subtract, right? I take my K each time. Okay, that looks right. Okay, so 2, 4, and 5. 2, 4, oh. I had one more if I is less than N. Nope. I consume the remainder of the string. You need to consider that. Hold on, this is kind of a hack. Yeah, so take 3, ABC. Then we take the rest. Here we take first one, then we take that one, then we take this one. Okay, that looks good. Oh, hold on. I don't want to take in this case the biggest. This is a corner case when you want to actually take less first. I wonder if we can handle the corner case completely separately. If one is equal to the length of the set of characters S, turn in. I just handle that as a separate use case, maybe? I don't know. Let's see what happens. Okay, so that's my brute force solution. And it is not correct. Output 3 is what we're expecting 4. Yeah, because I'm taking those. They're consecutive. I guess if they're consecutive, then I don't want to take them. And they're all the same character. I guess only if they're different characters, right? It's greater than 1 is the length of the list of characters for that guy. Length of the set. Right, okay. Uh-oh. It's not right then. Length of the set. Maybe consume it from right to left instead of left to right. No, that doesn't work because you have to, it's the prefixes we care about, right? Okay, So this is not correct though, right? So brute force is not correct. It's okay for the example test cases, but for this one, it's coming up short by 1. It's a suboptimal solution to consume JJ. The other alternative is start from K. Is 1 until this. Do you have them both directions? Oh no. All right, let's do this. Fast equals count. Let's reset I back to 0. Reset count back to 0. And let's just do it in the opposite direction. All right, let's do this. Total hack. Okay, so K is 1. While K is less than equal to this guy. K plus equals 1. If let's call this guy last. Equals last. We have to consume it all. I plus equals K to break at the smallest. Okay. And then, okay, so best is maximum, best second count. Okay. It's ugly, but maybe it'll work. Nope. Okay. Not quite. I mean, that was a hack anyhow. Okay, how much time do I got left? I got 14 minutes. I think I'm going to call this a day for now, and I'll come back and try to upsolve this with a fresh mind. It's cool to take a stab at the key for they're pretty hard usually. So that's cool, right? 4,000. I wonder if this is just like a dynamic programming recursion. All right. Christian, is this just like a knapsack? Either we consume it or we don't. It would be like DP. Is this DP? Each candidate K link to consume optimally. Choose the maximum as best And we could recursively branch out and just go recursively consider all k possibilities. Right, I guess we can code that here real quick. Go one, we have to consume the entire string at the end here. Okay, so for k in range 1 to n minus I, by 2 plus 1, let's be inclusive. So if a sub I to I plus k is equal to sub I plus k to I plus 2 times k, then it's a candidate. Best candidate equals 1 plus go plus k. Best equals maximum best candidate. These are the reductions we can make. And in the base case, I plus k is equal to 1. Consume the whole thing, but if none of these are good, it's okay. So if not best, then best is 1. We consume the remainder of the string. Should turn 0 in this case. Something like that. Oh, okay, yeah, maybe that works. See if I memorize this thing, maybe that's cool. 48. I was just gonna go TLE. Yeah, this is TLE. I need memoization, right? Okay, memorize this thing. Ooh, big money, no whammies. Maybe it'll work. Oh no. Okay, this is a good try. Yeah, this is a good try. Okay, how much time do I have left? 8 minutes. 8 minutes remaining of the contest. Okay, how to optimize, right? To optimize this solution. That's a good question. Oh, wait, hold on. This one's that corner case, right? Okay, hold on. So if one is equal to length of the set of characters, then we'll return in. Hey, that's cool. Just like that. Bam. It should be just the cardinality of the string. Maybe it's cool. Maybe, maybe not. Big money, no whammies. And if that doesn't work, yeah. What? Is there like a different character in there somewhere? What is this? There's a D in there, yeah. Okay, I'll turn in that 1001. But when I submit this thing in TLEs, all right. Well, yeah, it's a good try. 6 minutes left. How am I going to make this more efficient? That's the key question. Hmm. I'll let my subconscious work on this. Yeah, right. Let's upsolve later. Well, I mean, I can look at it for 6 more minutes, I suppose. Well, I suppose we could flip it from top down to bottom up. Maybe go from top down to bottom up. That would reduce the recursive stack overhead. The maximum I for all TPs of I. And we can try it. All right, we have a few more minutes left. All right, I have 4 minutes. Maybe I can solve it. Let's see. Just need to end, I think. Maximum, whatever's in TP. One to that inclusive. Right, basically the same stuff. Fast, let's get one. Whoa, there's no goes DP plus K. That means we have to go in the reverse direction. In down to 0. -1. All right, so building off those previous ones. So we can try with the easier Test case examples for validation. Okay, that looks good. Big money, no whammies. It's 3 expected 1. So I need to build off of previous K in this direction then. No, that's not right. Okay. All right, I got some work to do. To do fix bottom up, or come up with a better game plan. Okay, we got 2 minutes. Oh, it should be initialized to 1 to consume at least 1. Right? Let's go. And down to R9. It's okay. Let's go this direction. Yeah, so down to 0. Inclusive. Should be 1, not 3. Oh, okay, so it's still not right. Biggest, smallest, or smallest, biggest. I think that's fine. Yeah, this logic's just off. I'm just throwing stuff on the wall to see what sticks now. Recursive stack on lines in this direction. Doesn't matter, I don't think, right? License K. Fast. Expect 1. Cannot be consumed. Yeah, I need to go in this direction. I minus K. Oh, let's see. I 2 times K plus that in this range based on the past. Is that right? No, this is right and that's wrong. Okay, I'm a little bit off, but maybe in the right direction. Yeah, thanks for watching. Catch you next time.